Hello and welcome. My name is Ognjen Petrovic and I am an applications engineer at Typhoon HIL. In this walkthrough, we will be focusing on the new features and improvements included in the 2026.1 software release for Typhoon HIL Control Center. Join us as we explore in more detail what this release has to offer. In the device configuration table, you might notice that the DC-DC converter solver has been replaced by the new UltraCore Solver. The previous solver used a fixed 25 or 50 nanosecond time step depending on the device generation. The new UltraCore Solver significantly improves time resolution, allowing you to run simulations of specific converter topologies with a time step equal to a single FPGA clock period. In practice, this means you can run these converter topologies with a 6.25 nanosecond time step on HIL 402, 602 Plus and 604 devices, 4.5 nanoseconds on HIL 101 and as low as 3.5 nanoseconds on HIL 404, 506 and HIL 606. It achieves this by executing part of the model with a very small time step known as a solver time step. This solver time step is fixed, meaning it operates independently from the simulation step used for the rest of the model. The new UltraCore Solver effectively doubles the supported switching frequency range while maintaining a similar FPGA resource footprint. Starting with the 2026.1 software release, 3 converter topologies are supported by the UltraCore Solver: dual active bridge, resonant converter and active clamp forward flyback. For example, in e-mobility applications, this means faster and more precise testing of onboard chargers and DC-DC converters. It's a drastic improvement that helps when working with high-frequency designs and evokes a level of precision that ensures your designs can meet the highest standards of efficiency, reliability and safety, while minimizing design risk and accelerating time to market. We are proud to announce that we have developed a new block set for Simulink called the Typhoon Blockset, which allows you to easily establish co-simulation between Simulink and TyphoonSim. You can download this blockset directly from your subscription account under the Typhoon Blockset tab. Typhoon Blockset is designed to support a Simulink-based control development workflow and introduces a new Simulink library with 2 main blocks. One of them is a Typhoon model block. This block contains the Typhoon model directly, eliminating the need for external TSE files. By double-clicking the block, you can open a schematic editor and interface with the application. These block's ports are used for signal exchange between Simulink and TyphoonSim. The other block is the Typhoon settings block. This block allows you to force the model compilation and configure the execution rate when using a fixed-step solver. We hope this feature will be helpful for users who are already familiar with the Simulink environment and enable even more efficient use of our toolchain. Importantly, it allows you to test your existing Simulink control model directly on your TyphoonSim power stage model, without the need for duplicate models. Look out for our dedicated video tutorial on Typhoon Blockset for more information on how to use this feature. Continuing with the major updates, we've added a new component to the Functions and Tables section of the signal processing library, called TML Function. This component allows you to implement custom behavior using an arbitrary function written in the Typhoon Modeling Language, or TML. Typhoon Modeling Language is a programming language used to describe dynamic systems, and it enables component development at a much higher level of abstraction compared to the existing C or template-based approach. As a result, the code is more readable and easier to maintain with fewer hidden programming errors thanks to comprehensive analysis. TML also provides native support for tensor types. In the Component Properties window, 2 tabs are available: The General tab allows you to define inputs, outputs, global variables and parameters, while the Functions tab is used to define custom initialization, output and update functions. TML includes its own library of mathematical functions similar to C and MATLAB. Compared to C and MATLAB, TML provides native support for tensor-based computation, allowing tensors to be passed directly to built-in functions such as sine, cosine or log without the need for manual looping or indexing. Operations are applied element-wise or through explicitly defined reductions depending on the functions used. With TML, you can create complex system behavior more easily and with greater confidence. Its tools help you avoid errors and speed up your workflow, making modeling smoother and more reliable. As part of the general improvements in this release, we've extended support for semiconductor loss definitions defined in XML files. Previously, only table-based loss definitions were supported. Now you can also use formula-based definitions, as well as hybrid XML files that combine tables and formulas. If user-defined variables are present, they are accessible directly from the component's mask. Options for loading loss data have been reworked. A new Load Data From property has been added, allowing you to load losses from user-defined tables, including table-only XML files, as well as from XML files that can contain table-based data, formula-based data, or a combination of both. The thermal network data is shared between these options, meaning that if any data defined in one option will automatically be applied in another until it is modified. In addition, the Output Settings component has been renamed to Initial Settings to better reflect the component's capabilities. Now we will turn our attention to communication updates, starting off with general communication updates this release has to offer. The SFP setup component has been redesigned, and the component properties window now includes two tabs instead of one: General and SSL. This redesign introduces per-channel configurability, providing more flexibility when working with SFP connections. Additionally, support for synchronization and slave mode have been added. Support for multiple serial send components has also been added, allowing up to 4 serial send components to be used on a single HIL device, instead of the previous limit of 1, with each message distinguished by its start-of-frame property. In addition to the previously available standard components for CAN-FD communication, new components have been introduced. These include CAN-FD Pack and CAN-FD Unpack, which handle conversation between physical signals and raw data, as well as CAN-FD Raw Send and CAN-FD Raw Receive, which manage raw data transmission and reception on the CAN network. By separating the data packing and unpacking from the actual transmission and reception, these components provide access to raw data before transmission and after reception, enabling custom data processing, manipulation, and a wide range of advanced testing scenarios. Continuing with communication updates, let's now turn our attention to grid modernization. In addition to reading VLAN settings from a configuration file, support for manual VLAN configuration has been added for IC61850 Goose protocol components. You will find that the Enable VLAN tagging option is now available, along with configurable VLAN priority and VLAN ID properties. This feature increased network configurability and enables the IC61850 Goose protocol to operate within VLAN networks. TyphoonSim has received a major update. We are delighted to announce that for the first time ever, TyphoonSim standalone is available for Mac. Additionally, simulation preparation time has been reduced by skipping the GCC compilation step for the electrical part of the model. Testing on our example models showed a preparation time reduction of around 36%. We have added options for aligning and distributing selected elements in the schematic editor, providing you a much faster way of making your models clean and presentable. A new Reload Handles option has been added to the mask editor, allowing quick testing of handle modification by applying them directly to the loaded library and the component instances, without the need to reload the library. This option is available only when editing a library or tlib file. Finally, we would like to highlight the Quick Tag Insertion feature, which allows you to create a complementary from or go-to tag simply by dragging and dropping from a source tag. In addition, tag names are now automatically suggested, so existing go-to tags are listed when creating a from tag, and vice versa. This removes the need to manually type tag names and helps prevent connection errors. Thank you for joining us on this video walkthrough of our 2026.1 software release of Typhoon HIL Control Center. We invite you to test out these new features in your projects and provide us with your insights and experiences. For more information and updates, stay connected. Thank you for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL.Academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.